Okay, so let's look at this assignment here, and then I want to talk about a couple of things, and then I'll give you another assignment to continue practicing this stuff. So let's see. Homework for today was to take our previous assignment, which was that countdown where we went from 100 down to 0, counting by tens. And pull it into a function called show countdown that allows you to control the different aspects of the countdown. So we should take in a starting number. So previously that starting number would have been 100. So here's that example. So it would have been 100 down to 0, step by 10. And that would be exactly what the previous assignment did. And then here's a second example call to it where maybe we start at 34, go down to 5, step by 4. So we want to write a function generically so that we can, remember we talked last time, functions are reusable chunks of code that we write once and we can call multiple times with different inputs. So we want to write it generically so that we can call it multiple times like this. So let's go ahead and let's write inside of show countdown. We'll write it identically to what we wrote last time, and then we'll start changing over the variables so you kind of see how we take it from the specific to the generic. So I'm going to just go ahead and gut what we have here. Oh. All right, so I'm going to have a function called show countdown. And this is going to take an int. Actually, let's just start it off with no parameters since we're going to write it hard-coded in there initially. Let's just take it one little step at a time. So I prototyped it up there, then I'm going to actually write it down here. Because remember that if we talked last time that this allows us to tell a C++ compiler that it's going to be running into a function named show countdown, but we don't have to implement it till down here. That allows us to have multiple functions that call each other, and then you don't have a chicken or the egg problem where one function wants to call another function that's written after it or something like that. So inside of show countdown, we're going to literally write the code that we wrote last time and countdown. So we'll do a for int I is equal to 100, I is greater than or equal to 0, and we'll say I is equal to I minus 1. So we're going to count down from 100 to 0, stepping by 1. In this case, I know that some of you took the shortcut and you stepped by tens, but we're going to step by 1 here. And then we're going to ask the question. We're going to say, if the current value of I, when divided by 10, has a remainder of 0, then we're going to go ahead and output that current value of I. All right, start at 100. So 100 first time through, 100 divided by 10 is 10, remainder 0. So we'll output the 100, spin back up. I is now 99. 99 is not evenly divisible by 10, so we'll go through here without printing the next 10 times, then we'll print again, so on and so forth. We'll go ahead and now call our show countdown from within main. So we've written this function, and right now this function has everything hard-coded in it. So this is not a very good use of a function other than just keeping main nice and concise. All right, so we'll go ahead and run this guy, and there is our countdown 100 to 0. Okay, so now what we want to do is we want to make this guy more generic. Okay, so I'm going to do one little step at a time for this. So I'm going to create a int here. We're going to call this start value, because this is usually what beginning programmers struggle with, is this replacement thing. So I'm only going to replace one variable at a time so you can kind of see it happen. All right, so I'm going to have my function take in a start value, And all I'm going to do is I'm going to change this 100 here that I have hard coded. I'm going to change it to start value, whatever that whatever was passed in, that's the value we're going to start at. Okay. But I'm not doing anything else. Everything else we're going to leave hard coded, even though we're going to make those things generic, more generic as well. So now, in order for it to do the same thing it did before, I'm going to pass in this 100. When I call show countdown, I'm going to pass it a 100. A 100 is going to come in as this input. And when we have this loop here, it's going to start I off at whatever you passed in. In this case, it'll start I off at 100. So when I run this now, it's going to have the identical output as it just had a few minutes ago. But the way I got to that is by actually passing in my starting value to this function into this new parameter I put there, and then using that parameter inside of here so that we can have a generically executing function. So go ahead and run this. See, I still get the same thing, 100 down to 0. Okay, and just real quick, I'll change that to 50 instead of 100. I didn't change my function at all. I just changed the value I'm passing into the function, and now you see it counts 50 down to 0. If I wanted to start this guy off at 39, the first thing I'm going to see is a 30, then a 20, then a 10, because 39 is not evenly divisible by 10. All right, so you see how changing the value that I pass in changes this. And show countdown, I can call this guy multiple times. So I can pass it on 39, I can pass it on 300, for example, and it's going to do the entire countdown 2 separate times. First time it did 30, 20, 10, 0. Second time it started at 300 and counted down by tens. Okay. But now for the assignment, we're supposed to make it even more generic. So not just let us choose what the starting value is going to be, but also what the ending value is going to be. So we're going to put in int end value. So our function's not going to take 2 different inputs. So just make sure however you prototype it, your implementation function matches. So now what I'm going to do is I'm going to take that variable end value, and I'm just going to replace that hard-coded 0 with that. So now this loop goes from I starting off at whatever start value is, whatever was passed in. It keeps going as long as I is greater than or equal to whatever end value is, whatever was passed in, and decrements by 1 each time. So now I'm going to go, if we want to go back to our original, I'll pass in 100 and I'll pass in 0. So a starting value of 100, an ending value of 0. So now we're right back to the original countdown that we had. All right, so there's our 100 counting down to 0. But now I can change this. I can say 50, and I can say I'm actually going to count down to 5. I'm changing my starting value. I'm also changing my ending value. And because I've written this code to generically operate off of what those inputs were rather than hard-coded values, I can now call this guy multiple times, passing it to different inputs and presumably getting different outputs. So I'll go ahead and run this guy again. It's going to count down from 50 to 5. So I'm going to see 50, 40, 30, 20, 10. I'll never see the 0, though, because we stop at 5. So there's my 50, 40, 30, 20, 10. All right. And again, I can call this multiple times. I can call show countdown a second time, and I can say I want to go from 3 down to 1, or something like that, which is going to give me no output for the second one. So maybe it's a bad example in this case here. Let me just comment this one out so you will see that it's going to be nothing, but I'm going to start it at 3, count down to 1, and only show things that are evenly divisible by 10, which none of them will be. So my output is going to be nothing in this program. Okay. So, but it technically did what it was supposed to do. Started at 3, counted down to 1, only showed the countdown that was evenly divisible by 10. All right, so now we're going to add one more variable. we're going to say int. Did I tell you what to name that variable? Doesn't really matter, but all right, so let's call it I don't know, we'll call it show count, something like that. This is how often we want it to show the value. All right, so again, I'm going to replace my hard-coded 10 down here with whatever show count was. So if we want to see our original, that's 100, counting down to 0, showing it every 10. It's going to have the same output we've seen from all the other ones, but in this case, I'm passing in those 3 different values into these variables, and I write my loop here in terms of those variables. Start at whatever start value is, keep going as long as I is greater than or equal to whatever end value is, decrement I by 1 each time, and each time that I is evenly divisible by whatever show count is, we're going to display it. So when I call show countdown with a 100 for starting value, a 0 for ending value, and a 10 for my countdown, we get our original behavior, but the function was written generically. So there's our 100 down to 0. All right. And then I gave you an example of a second call to this guy, where I'll call show countdown with a 34 to a 5, stepping by 4. So I'll start off at 34. I'm going to go all the way down to 5, but I'm only going to display things that are evenly divisible by 4. I named it a little bit different naming convention in my code. There we go. Gotta put my semicolon there. All right. So there's my countdown: 32, 28, 24, 20, 16, 12, 8. All right. So that's counting down from 34 down to 5, only printing out the values that are evenly divisible by 4. All right. So this is the solution to the homework assignment. So you have that, and hopefully you understand the way I walked through that is, you know, was understandable, and breaking it down into the individual pieces, showing how these variables played a role down here generically. Hopefully that makes more sense now. All right. So now, I'm going to go ahead and, well, I'll put that up on Slack here at the end. I'll give you a link to the code. Put it in the presentation. So there's that link. All right, so now I want to go a little bit further and show you some things that I mentioned in class last time, but I really want to drive the point home. And actually, I can start off by driving the point home right here. Our show countdown, if you remember when we looked at the syntax for a function, we said it's the return type, followed by the function name, followed by the comma delimited set of inputs, or parameters is what they're usually called. All right, but in this case, my function just does a bunch of stuff. It doesn't actually return a value. So since it doesn't actually return a value, we would advertise that the return type here is void. Okay, void means nothing. You have to have a return type, but that return type can be nothing. All right, which implies you're not going to return a value. All right, so let me actually grab the share link for this one more time here, just so you have that updated. Okay. So now to drive that point home, I'm going to put this into the slides. All right. So functions can either do something and not return a value, or they can do something and return a value. There is a distinct difference. Typically, when we're doing something and not returning a value, we might be printing something to the screen. Understand that when we display something to the screen, that is not returning something that can be used somewhere else in your program. And I'll show you an example here in a minute. It is just displaying something. And this is a concept that beginning programmers struggle with. Okay. We can ask a function to display something, but that's not asking it to return an answer to us that we can then use for something else. Or we can have a function. So we might have a function do some logic on the inputs and then return the answer to be used somewhere else in the program. This does not require that it is ever printed to the screen. Okay, so understand that you might still print something to the screen inside of a function that returns a value. You just don't have to. All right. Whereas if you're having a function that does nothing or returns nothing, you might choose to display what it's doing. So in this case, we're displaying a countdown, or you might, when we get into a little more advanced programs, you might update a database or something like that. And you might not give any indication that it happened. You just know that it happened. So it doesn't return a value. It doesn't display anything. We just trust that it magically did its thing. Okay. So let's look at a couple of examples here. So I'm going to write a couple more functions. So I'm going to say void do something, but don't return a value. So they're very verbose function name. And we're going to take in some number as a parameter there. And then I'm going to have a separate function here. Let's say do something and return a value. So we have two different functions. I'm going to make both of these just take in a single input. And we're just going to do something frivolous with that input. All right. But the second one, I'm going to have return an integer. All right. So the first one is going to return nothing. And its name is do something, but don't return a value. The second one is going to return an integer, and it's called do something and return a value. Both of them are going to take numbers and as parameters. So let me steal these two lines. We'll come down here. We're going to implement this guy. All right. So for the do something, but don't return a value, why don't we go ahead and find the largest number that evenly divides number? Let's just start dealing with a little bit more complex algorithm. So we're going to assume number is some positive value. So we want to find the largest value less than a number that evenly divides number. So we're going to start off at number -1, and we're going to keep working down to 1, because we know if number is 10, for example, we know that number will be evenly divisible by the number 1. Every number is evenly divisible by 1. We hope to find some number in the middle that evenly divides it. So for instance, 10, 5 evenly divides it. Okay. So we're going to start our loop off. So we're going to say for int I is equal to number -1. All right. So in our example where I said number might be equal to 10, I'm going to start I off at 9. I'm going to keep going as long as I is greater than or equal to 1. And each time through, I'm going to say I is equal to I -1. All right. And what we are going to do is we are going to print the first value we find that evenly divides this guy. So I'm going to ask the question, if number, when divided by the current value of I, has a remainder of 0, if I am currently looking at a number that evenly divides number, then I'm going to go ahead and output, display to the screen that value. Okay. Just so you can see this here, I'm going to go ahead and take these guys out of main. I'm going to go ahead and call this guy passing it a 10. All right, so do something, but don't return a value. I'm going to pass in a 10 is going to come into number. We're going to start I off at whatever number is -1. So I is going to start off as a 9 in this example. Keep going as long as I is greater than or equal to 1. Decrement it by 1 each time. So the first time through the loop, we ask the question. Well, the first thing we do is we ask this Boolean, the question around this Boolean expression. We say, is the current value of I, which is 9, is 9 greater than or equal to 1? It is. It is greater than or equal to 1. So we're going to ask the question now. Is the current value of number, which is, in our example here, 10, when I divide it by 9, the current value of I doesn't have a remainder of 0. It does not. 9 does not evenly divide 10. So we will not do this, but we will decrement I. I is now 8. Is 8 greater than or equal to 1? It is. Is 10 evenly divisible by 8? It's not. 8 becomes 7. 7 greater than or equal to 1? Yes. Is 10 evenly divisible by 7? No. 7 becomes 6. 6 becomes 5. Is 5 greater than or equal to 1? Yes. Is 10 divided by 5? Is 5 evenly divisible, or is 10 evenly divisible by 5? It is. So we will output a 5. Okay. But we keep going. So I outputted the 5. Now we spin back up. 5 becomes 4. 4 greater than or equal to 1? It is. Is 10 evenly divisible by 4? It is not. So don't print anything. 4 becomes 3. 3 greater than or equal to 1? Yes. Is 10 evenly divisible by 3? No. So don't do anything. 3 becomes 2. Is 2 greater than or equal to 1? Yes. Is 10 evenly divisible by 2? Yes, it is. So we'll output a 2. And then 2 becomes 1. Is 1 greater than or equal to 1? Yes, it is. It's equal to it. So then we say, is 10 evenly divisible by 1? Yes, it is. So we'll print out the 1. 1 becomes 0. Is 0 greater than or equal to 1? It is not. So this loop ends and this function ends. We never returned a value. We displayed several values in here, but we never returned a value. It's very important you understand that difference, especially when I sometimes will ask questions of write a function that does something and returns yada, 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 or write a function that does something and displays to the screen some value. Understand the difference between those two. All right. So for right now, I'm going to go ahead and run this with a 10. We just walked through that code. So we should see it display to the screen a 5, then a 2, then a 1. The 3 numbers less than 10 that evenly divide 10. There's the 5, there's the 2, there's the 1. Okay. Again, this function advertised that it does not have a return value by putting void here. Inside the function, we never return a value. So we stayed true to what we promised. We promised the function was not going to return a value, and we indeed did not return a value. But we did print some values out in there, which is different than returning a value. All right. So now let's look at kind of the same logic. But let's return that first value that evenly divides 10. So I'm going to grab this exact same code here. I'm going to put it inside of this function. So now this function is called do something and return a value. It's going to take in a number, but I've advertised that it's going to return an integer. And what I'm going to put a little comment here. This guy returns the largest value that evenly divides number, the value that was passed in. So inside here, instead of printing something out, when I find a value that evenly divides my input, I'm going to return the value I found. All right. And there's an important piece here with the return keyword. Return keyword makes a function immediately end. That's the first thing it does. It makes the function end. Notice that I did not say it actually returns a value yet. So which implies that you could actually use the return keyword even when you're not returning a value. You can use it to kill a function, to make it end immediately. Optionally, you can send a value along with the return to make it available to another part of the program. All right. So we can optionally return a specific value. Now, realistically, a majority of the time we return something, we will be returning a value. We will be taking advantage of this optional piece here. Okay, but we don't have to. We could use return just to end a function. And there will be examples we'll see where we do that. Okay, so that's what the return keyword does. So what I do here is again, if we assume that my example here, number comes in as 10, and we do the exact same thing we did before, we walk through this the same way we did before, and we finally get to that number 5, right? I is 5. 10 divided by 5 is 10 evenly divisible by 5? It is. Before, what did we do? In this other function, we printed it to the screen. We did not return it. We printed it to the screen. But what I'm doing here is I am going to return that value 5, which makes this function immediately end. I won't hit the 2. I won't hit the 1 because my function died when I was 5 because I returned right here. Okay. So this guy is called do something and return a value. So instead of calling, here, I'll comment it out for a moment up here. So now I'm going to call this other function. And I'm no longer calling the one that prints stuff. So now I'm calling the do something and return a value. I'm passing it in a 10. That's this guy down here. We start off at 9, keep going as long as I is greater than or equal to 1, decrement by 1 each time. So same exact logic we just walked through with the other function, except the very first number I find that evenly divides it, I'm going to return that value. Okay, which in our example here, the first number that we'll run into is the number 5. All right. Now, if I had a live audience, I would ask the class, what would we expect the output of this program to be? And what I'm sure somebody would say is, oh, it's going to print a 5. Because we know that inside here, we are returning that 5, given an example where number is equal to 10. I passed in a 10 in to number. And ultimately, I can walk through this logic and I see, oh, I will return the number 5 because when I is equal to 5, it is evenly divisible. 10 is evenly divisible by 5. So I'll return that 5. All right. So you'll say, oh, it'll display a 5 to the screen. But when we run it, we see that's not the case. It displays nothing to the screen. Why? Because what ended up happening here is this line right here in this example, this line boils down to a 5, but I did nothing with it. I got the 5. I just didn't do anything with it. I could have directly printed out that 5. So instead of doing nothing, I could say, okay, well, whatever this guy boils down to, I'll just go ahead and display it out here. I can choose to do that. There's my 5. Okay, similarly, I can say, okay, well, I'm going to go ahead and store whatever that boils down to into a variable. So maybe I call that guy answer. So whatever this guy boils down to, I'll store inside my variable called answer. And then maybe I decide I'm going to go ahead and print out answer. Or maybe I decide to do something with answer. So maybe I say something like answer squared is equal to answer times answer, something like that. So I'm going to take the result of this function, store it in this variable, then create another variable that is the square of that answer. So 5 times 5 is 25. And then maybe I go ahead and print out answer squared. So now I use the result of this function in some other math problem. I did something else inside my program with that value. And then ultimately I output it to the screen so the user could see the result of using that value. And there's that 25. Okay. So the real thing to focus on here is the difference between having a function do something and optionally just display the value to the screen but not return anything, or have a function do something and hand the value to whatever part of the program called it so it can do something with that. Okay. Both the one is not better or worse than the other one. You got it's whatever's the right tool for the job, for the thing that you are currently doing. Okay. So for your homework, that I'll go ahead and actually, just to give you some extra time on it, I'll go ahead and make it due by let's say end of day Friday, and then I'll make your Thursday assignment due before Tuesday's class. So I'll give you a little bit extra time to work on this first one. I'm going to give you kind of a small example where I ask you to write a function that does something, but does not return a value. And then I'll have you write another function that does something and returns a value. All right. So you'll see those two things. I'll try to make it a little bit kind of a practical function that, you feel like, oh, that's what that guy, that's how I might use that. All right. So I'll go ahead and put that up on Blackboard so you have the homework. I'm going to think about it for a few minutes here rather than do it live on the video. I want to give you something that gives you enough practice but doesn't confuse you too much. So if you have any questions, feel free to email me or message me on Slack. Again, you're going to still have the quantum stuff here in the next 3 classes with Waleed, but I'll continue to put these videos up so you can hopefully keep up on your normal programming stuff, and so you're getting twice the value or something like that. Okay, well, I will leave it there and I'll upload this video and look for the homework assignment.